Here it is.
Okay, hello everyone. My name is Terho Koivisto and I work for CONFIDEE. And what is CONFIDEE? CONFIDEE is the PCB partner making your PCBs compliant. And that is made pretty simple through our own IT platform, which is based on, or doing the regulatory and compliance more or less automatically. It gives you the transparency in supply chain, and of course it protects your uh, data and also protects your against counterfeit products. We have the headquarters in Oslo. We have regional offices around Europe and also in Australia. We are tier one partners for defense and aerospace suppliers, or we say manufacturers. Of course, we have the ISO standard certification for aerospace and also for the uh, data communication, it says. And well, we are a highly experienced team. We say in average, we have approximately 20 years each of experience. My experience is like more than 30 years, less than 40. And it's been within manufacturing and we say technical sales and sales of printed circuit boards. Next. So to today's topic, everybody is aware of the standards our industry is working with. It's the IPC standards, and in those standards, you have more or less everything that is needed when you speak about the printed circuit board. You have everything from design, you have how to manufacture it, how to evaluate it, how to make the tests so the boards are as they are designed. And of course, there is a lot of text in those standards, but I'm sure that everyone involved in the way of the printed circuit board, everything from design to printed circuit board manufacturing to assembly to verification of the board to material declarations, etc., 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 should be aware of what is stating in the standards, particularly in these areas where you are working in. So as a printed circuit board supplier, we need to know about the design rules, how the PCBs are designed. We need to know where the boards are assembled, so how the boards should look like and how they should behave in assembly. But also, of course, the main importance for us is the manufacturing or the manufacturability of the printed circuit boards. Next. And since this seminar is more or less regarding the design or the interference between design and production, I'm sure that a lot of you are familiar with these IPC standards regarding the design. The generic is the IPC 2221, which is then split to down standards for rigid, for flex, for, well, more or less everything which includes design. And lately, we say within the latest 10, 15 years, unfortunately, I've seen a lot of companies missing to adopt the IPC standards. Instead, I can see that they are making shortcuts, making their own standards in some way, or making, we say, different kind of, we say, new ways to do things. Of course, IPC is not the fastest one to adopt the new things that's in the market, but IPC is the foundation of how the boards must be designed to kind of achieve the whole, we say, the value in the whole supply chain. So if you do not do things as they are supposed to be designed, how can you then evaluate the boards? How can you then make sure the boards are manufacturable? How can you make sure the boards are solderable? How can you make sure they are passing these tests? So a check, or we say a study how the designs should be made, should be done and evaluated by each and every designer. Next. Very simple statements, which is in the IPC 2022, which is the design guidelines for rigid boards. And there, the designer, as they said, the designer of the printed circuit board needs in a minimum the generic section of those chosen technology. And especially the lower part, the failure of all information available prior to start the design may result in a product that is difficult to manufacture. You can also read impossible, or exceeds the cost predictions. And there I see more and more issues with this, because I see that the designers are making designs. They do not communicate with their purchasing or their sourcing departments. They do not communicate with the suppliers. So a lot of things could be avoided instead of making the design, and then when the boards are ready for production, to need redesign, to re-evaluation about the materials, etc., etc. So again, I don't know how many designers are listening today, but this is of most importance, that communicate with both your sourcing department of your selections of materials, of design rules, etc., etc., but also consult your PCB suppliers, because they know the materials, they know what is doable and what is not. Next. So why is this important? It's important because here I took an example what could happen. So we have a designer who is decided to make a Formula 1 car, the fastest Mercedes with the best driver, Mika Häkkinen or Kimi Räikkönen, the Flying Finns. Then when the design is ready, he or she is going for the procurement department, for the project purchasing, or for the procurement in general. And the procurement is saying, okay, guys, now we have the designs ready. So let's make the toughest vehicle ever, a 4x4 with differential locks, high enough for ground, and a V8 engine. Can you do it? So we have a designer who thinks that's going to be a Formula 1. We have procurement or production thinking it's going to be an SUV. And well, it finally ends up at the PCB manufacturer. I choose Land Rover in this case because it's the only company probably doing only SUVs. The guys are really confused. The designs can be done according to IPC class 1 standards, and then suddenly the procurement or the we say project management is requiring design class 3. So you have a mismatch from the design to the manufacturing. So again, discussion back and forth to make sure that when you start to do your drawings for the Formula 1 car, that your project management also understand that it's a Formula 1 car you are building now. It's not the SUV. Or the other way around, of course. So how do we see it in the printed circuit board then? Well, most commonly you see it just the registration. If we're going now to the registration, the tolerances, what you see is the annular rings. That's the first side, because you seldomly have any other equipment available on the shop floor. So what you can see is using your magnification glasses to just look at the printed circuit board. And of course, why do we need the 150 annular ring? Because it's taking so much space on the board. Of course, we have the approvals of different classes, IPC class 1, 2, and 3. And if you take the next slide, here you have the verification, how it's looked at it during the manufacturing or the acceptability of the printed circuit board. So we say class 1 is for consumer electronics. Class 2 is mainly made for we say more or less professional electronics, and class 3 is the best one, which is then for, we say, aerospace and stuff like that. So what are we looking at here is that why is the annular ring required? Of course, we have a tolerance in everything we do. So what you are just looking at when you see the board is looking at the tolerance of the drilling and the outermost layers. But we remember that in the board there is often up to 10, 20, 30 layers that needs to kind of adopt the same regulation. So if you look at the IPC standard or requirements, it says, for instance, that, okay, for class 2, in the inner layers, I think it was, it can just hit or have a breakout, so it hits the edge of the annular ring. And for class 3, you require a minimum annular ring of 25. Next. Now, to make this more complicated, we have the tolerances. And in everything we do, not only in printed circuit board, but also mechanical, everything has the tolerances. Okay, when you do a printed circuit board or when you manufacture one, you have a lot of tolerances, which is actually influencing in the registration. So here is a pretty, we say, simple mathematics, how you normally do it. You have tolerance 1, tolerance 2, 3, 4, 5, etc., etc. But luckily, you do not need to just accumulate it one after another, because otherwise we will not be able to make none of our, we say, today's products in a printed circuit board. Therefore, it's used as a so-called square root method, which you do is that you calculate the not the worst case scenario like in the example below, that you have 25 micron, 3 processes with 25 microns tolerances, and the total tolerance would be 75 micron. Instead, you will have the 25 square root of that, or up to 2, and then to make a square root method. So therefore, you will have a, we say, better tolerance. And this, why this is calculated like that is that when you're doing your processes are done or controlled with SPC, you will hardly or almost never end up that your all processes will be on one end or the other end of the mean distribution. So therefore, the tolerances for 25, 25, 25 would only be 43.3 in reality. And that is the way it's calculated at the manufacturing of printed circuit boards. So we are not calculating plus, 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 but it's calculated with the square root method. Next. So during this speak, I will use terminology. I'm speaking about production panels, and then I do not mean the panels that are supplied to our customers. I mean the production panels that are used in printed circuit board manufacturing. So usually they are 610 times 530, 610, 460, or 406, 460. It's depending on which factory, what kind of product, etc., etc. So there is a certain variety in the panel sizes, but most of the factories are having, we say, one standard panel, and that's due to automation. I'm going to speak about LDI, which is laser direct imaging. I'm going to speak about films, which is the, we say, the older way to do the photo exposure of both inner layers, outer layers, and solder mask. I'm going to speak about inner layers, outer layers, and buried layers. Next. So now to the PCB and what is the tolerances coming from? First of all, you have the film or the LDI, depending on which technology is used. You have the layout for the laminate, not the whole board, but the individual laminates inside the board, but also the whole board. So how much of copper you have, how much is on bare laminate. You have the laminate itself. It's always shrinking. So each time a laminate passes the TG, it will shrink. So when the laminate is taken from the shelf for production, and it's 100 centimeters long, for instance, after its first time passes the pressing, it will not be the same length. It will be reduced. Then you have side-to-side registration because you're going to make the patterns on both sides. There you have a tolerance that has an influence. Then you have laminate to laminate registration. That's during the pressing because you have the inner layers 2, 3 and 3, 4. You have stack to stack registration. It's when you're doing either micro wires or if you're stacking sequential blind wires. You have the drill, the mechanical tolerances in drill and drill wonder. And then, of course, you have the final exposure of outer layers and the solder mask. These are actually all the tolerances that are in a printed circuit board. And now we have to remember what we looked at in the past, that we need to have these all within 150 microns. So it's a tough game. But okay, let's continue. Next slide. First of all, we have the film and the LDI. So if using, we say film is used mostly when you're doing larger production batches. I would say that a lot of today's companies are going over to use the LDI, especially in smaller series and in fast deliveries. But still, films are used widely, especially in Asia, where the volumes for the productions are bigger. So what you need to remember is that when you plot out the film, it needs to be temporized after the production, after it's plotted for 24 hours, because the heat in the laser will kind of give energy and heat to the plastic, so it will expand. So you need to temporize the film to be adjusted back to its original length for 24 hours. But you also need to consider is the humidity and temperature where the film is plotted into the darkroom and where the film is used, because that needs to be in the same we say environment. So the temperature and humidity where the film is plotted and where the film is used needs to be the same. And of course, you have the mechanical tolerances of the plotter. Then before we go to the board itself, we start to kind of give you, or I will give you a small details behind the theory of the registration. Most of the registration systems are based so that the best registration and all the measurements are starting from the central of the production panel. And now we need to remember that it's the production panel, so it's 510, 610, 530 or something else. So it's much bigger than the panels that are supplied. The first thing you do is that when you, at the same time, when you do the exposure of the image to the inner layer, you also expose fiducial marks or marks at the end of the or edges of the panel. And these marks are used to later on measure the behavior of the laminate during production, optimize drilling, and also give feedback to the guys at the cam station who are estimating the films or the behavior of the laminates. So the feedback from these products are fed back. So when the first batch is made, then when it's measured, then the feedback is given back to the CAM or the product planning, so they know for the next batch that, okay, these laminates in this product with this layout behaved like this. So next time the batch version number 2 is coming, then the we say expands can be modified according to the right measurements from the batch. What the laminate does, as mentioned, it's shrinking, and the shrinkage is dependent on the manufacturer's grade, the brand, etc., etc. It's depending on the thickness. So a 0.1 versus a 0.8 laminates are shrinking differently. It's depending on the copper. So if using an 18 micron copper, or if using a 35 micron or 70 micron copper, it's shrinking differently. Depending on the layout, if it's a ground plane or if it's a signal plane, the shrinkage is different. It's depending on the buildup. What's the final buildup of your product? So is it going to be a 1.6 layer, 1.6 millimeter thick or 3.2 millimeter thick? It's going to have an effect on the shrinkage. It's going to have an effect on the shrinkage as well, what the nearest prepregs are. So if it's going to use an 7628 or 1080 or 2116 or whatsoever, it's going to have an effect on the shrinkage. And also how many boards are in the press, and also how many pressing cycles the laminate sees. So all this actually shrinkage, or we say the instability of the laminate, this is guessed by the production planning or the CAM operators first time the board goes into production. So of course they have a good database. They have collected the data since they've been using that material, but we need to remember that the shrinkage is also dependent on the manufacturer of the grade of the material. So if one factory is normally uses laminate X in their production, so they prefer the material X in the manufacturing. They also have capability of do the laminate Y. But why they prefer X is that they have much better data, how it behaves in different kind of stages. So when a manufacturer is suggesting that, okay, can we use this X because we have better in stock, etc., etc. So unless you do not know why, you have specified why, because the specification of the materials, which I will come later on to, is often that, why do you use laminate Y? It's because we always used it. It's the best laminate. We had it in this earlier project, and it worked fine. So if there is a necessarily to use laminate Y, then I understand why to specify it. But if there is not any particular reason why you should use Y, then as recommended by the manufacturer, use the laminate X. Next. Okay, then to the details. Side-to-side registration. So what you are doing when you do the exposure of the inner layers, you place films in your exposure unit. You adjust the films for layer 2 and 3 in this case. Let's play the first layer pair. 2 and 3 into your machine, and adjust those that they are exactly on top of each other. So now using the targets that were printed when you do the films that are printed on the edge of the board, they register the film exactly on top of each other. But again, there is always intolerance. The cameras reading the fiducials, etc., there is always a play. You have either automatic or semi-automatic screw threads which are giving its an own plane, etc., etc. But of course, the target condition is that when the board is exposed, you will have the bottom side and the top side of the pad, or layer 2 and 3 in this case, exactly on top of each other, as in the central line picture with the target condition. Next. By using the LDI, it's doing exactly the same way, but when it's doing the laser printing, or we say laser transfer of the image, it's also printing out fiducials on the side, which is then read by cameras when the other side of the laminates is exposed to kind of read. And of course, there is always an tolerance of the reading of the fiducials, but also the mechanics, general mechanics in the LDI. And again, the target condition is exactly the same as in the previous slide, that the pads on layer 2 and 3 are exactly on the same location on the board. Next. So preparing to LAM registration. Based on the registration marks printed out during the exposure of the inner layers, you will print out in the fiducials in the corners, and measuring those, and based on those, you will drill or punch holes to be able to registrate the stack. So the layer pairs 2, 3, 3, 4, 4, 5, etc., etc. So again, this is a drilling operation that is done either automatically, or it's a punching operation done automatically. Next. So after punched or drill the holes, you normally use pins. They can be 2 pins, they can be 4 pins. There is a lot of different methods to do it, but we say the process is more or less the same. So on using these punched or drilled holes, you have steel pins that is guiding exactly the laminates to the right position during pressing. It can also be that the pins are used, but before pressing, the stacks are welded or riveted together. But after pressing, the target condition is, of course, that all the pads on layer 2, 3, 4, 5, 6, how many layers there are on the boards, are exactly on top of each other. Next. But what is the reality? On the right hand, you can see the reality. They are never exactly on top of each other. There is always a shift. There is a shift between one layer pair. There is a shift always between laminate to laminate. And based on those now, the same kind of registration marks are plotted out or printed out on each layer. Based on these, they are using, or we say manufacturers are using an X-ray equipment to measure what the outcome of the guessing, or we say the stretching of your inner layers has been. So if you then look from the top, you look at the magnification, you see that the pads that should be exactly on top of each other are not on top of each other. So what the X-ray machine is doing is that it's calculating based on this information it gets from the panel corners where to exactly drill the holes to be able to put these boards to the drilling machine. And it's always a compromise. And if the guess has been totally wrong, we say the layer pair 2 to 3 has been out of bounds, so it's not going to fit. Already then at this stage, the manufacturer can see that, okay, we need to scrap this batch because we estimated the stretch factors wrong in the beginning. And now again, this information is sent back after the we say the drilling operations of the holes is sent back to the CAM or the product planning for the next batch. That, okay guys, be aware, this is stretching like this is stretching like this, etc., etc. And now when the manufacturers are collecting this data, they have a really good database for those laminates that they normally use, those buildups they normally do, etc. So the first time they manufacture a batch, which they never have done before, they need to make an estimates, and sometimes it goes wrong, and sometimes it we say they are lucky, so they hit the target. So what I would say about this, okay, go to the next slide. The drilling itself, after you have drilled the fastening holes, that drilling cannot be stretched. So that needs to be one-to-one, because this is what the customers are now seeing. This is the size of the board. So this cannot be stretched. Of course, if you have a big production panel and you see that you might have a problem, and you have a lot of, we say, small delivery panels, the panels that are supplied to the customers on the same board, you can, of course, play with the kind of having a different distance or giving a different distance for the drilling from panel to panel. But in most cases, the drilling is done exactly as it was designed at the CAM. But we have to remember now that the holes that you drill, if the customer specifies that the holes is 0.3, the suppliers or the PCB manufacturers are drilling with 0.4. Of course, there is a little bit difference if it's a press fit holes, because there it can be, the tolerances can be tighter or looser or whatsoever. But normally it's again drilled with 0.1 bigger drill bit. And now we have to remember that, okay, the 0.1 bigger drill bit is actually eating again a little bit of the tolerance of the registration of each annular ring. Next. Then we have a phenomena that is called drill wander. And what actually is happening is that even though the drill hits exactly the pad on the top, it bends randomly inside the product. And we have to remember that in most cases, the boards are drilled in stacks. So if you have a 0.8 thick board, it's normally drilled stacks up to 4, 1.6 stacks up to 3. So you have 3 products on top of each other when it's drilled. 2 millimeters stack of 2, and above 3.2 or 3.2 or bigger, it's 1 up. So actually you can start to drill and you put the panels on top of each other. Panel 1 and 2 are perfectly fine, but panel 3, you have a randomly, we say, drill bend, which is causing a reject then in the production. And again, this can be avoided by drilling only 1 up, but then if you drill only 1 up, then you need to kind of use the machinery 3 times longer. And when you use the machine 3 times longer, then of course it's going to be more expensive, and in the final end, it's the customer who pays it. Next. Then of course you have the next tolerance steps. It's the laser drill. Laser drill is little bit more simple because you just need to kind of target 1 layer down. So if you make a through drill, you need to hit each and every pad on the inner layers. But if you do with the laser drilling, then you only need to hit the layer just 1 layer down, so to say. Next. Then you have this stack to stack registration. So if you do, we say, sequentially build, if you have 2 8-layer boards, which is going to be finally a 16-layer board, you have 2 8-layer stacks that is going to be pressed together, the first stacks are seeing a shrinkage 2 times because they are 2 times going above the TG temperature in the pressing. Same goes if you have a blind and buried, which means that you have a from 2 to 7, and then the final products from 1 to 8. So it's actually seeing 2 shrinkages, and these shrinkages needs to be again considered in the pressing stage, or in the stage when doing the inner layers for the first time. So it's actually shrinking 2 times, not the first times when you make the core laminate from 2 to 7, and then in the final products when you are making it from 1 to 8. Next. And then, of course, you have the outer layer registration. Of course, this is what the user of the printed circuit board see. So the user does not see the inner layers that we've been struggling with. The user is only seeing the registration of the outer layers or the registration of the solder mask. Next. Then we go to rumors. I can say not daily, but weekly or monthly, I hear that, hey, why can't we use 120 or even 100 annular rings? Because I worked to a company making mobile phones back then in the 2000, and they were able to do it. Yes, if you do it again with stacked micro vias, very simple to do. You need only to register 1 layer at the time. Then you can, of course, because you need to only hit the 1 layer, just 1 layer beneath. So it can look like in the top picture. So if you make a microsection, these are fully approved by IPC and it works perfectly, no problem. But if you add a through hole, the first through hole you need to hit with, then it's totally bad. It's not going to work. Another thing is that when you hear often is that, hey, we have now been prototyping these boards and our prototype manufacturer made 20 boards which were really good for us, and now when I start to order 10,000 boards from you, why can't you do it? And the thing is that, well, the prototype manufacturer either used a small panel to be able to register it, or actually to make 20 boards it used only the middle of the panel that it supplied to you, and all the other stuff was just thrown away. And by that you can control the registration much more accurate, because as you remember from the beginning, we have always the best registration in the middle of the panel. Next. So, as a summary, designer's checklist. Use IPC design guidelines. And why is that? That's because that everything that will be done to your design is always going to use the IPC, different IPC standards as reference. Remember, this is not steel plate we are working with, it's a plastic. So there is always a tolerance, not only in the material, but also in the doing. Use minimums and maximums in design only where it's necessary. So do not use, I need to use 65 micron tracks to get the routing work under the BGA. Well, do not use it globally on those places. Wide it up to 100 on those places where it's not necessary. Specify the material properties, not the material brand. And there we come now back to what I was discussing about or telling about earlier, was that the different manufacturers are using different laminates. In most cases, an mid TG or high TG laminate, they are kind of more or less the same. So why specify something if it's not necessary? So specify what you really need to have from the laminate, not what it's called. Involve your purchasing at the early stage. And this is due to that we do not end up in the phase that, okay, I designed a Formula 1 car and my purchasing or my supervisors at the project management want the SUV. And involve the PCB suppliers in an early stage as well, because then they can guide you with impedance calculations, they can guide you with choosing the right materials, etc., etc. And also, if there is, we say, showstoppers in your design. In worst cases, I've seen designs done that a 16-layer board, which was done by microvia design rules and having 0.1 holes through the board. And if you're unsure, you will always have contacts you can ask. You can ask manufacturers, you can ask your procurement to help you to kind of find out, we say, the recommendations how to make the design. Of course, I understand that, okay, you need to challenge the PCB suppliers. That's of course understandable. Otherwise, we will be, well, still back in the 60s if the guys were not challenged. But you need to do it with reason. Do not challenge him just for fun, because that is going to just give you the cost of the board. Next. This was the last slide. And if you have questions later on, you will have my contact details either by email or telephone, and I will be happy to answer you those questions. Thank you.
Jo,